welcome you to our webinar, Finding Solutions to Our Engineering Challenges. This is session 2, and it's titled Air Quality. It's a collaborative initiative between the National Institute of Higher Education, Research, Science and Technology, better known as NIHERST, as well as the Association of Professional Engineers of Trinidad and Tobago, APETT. Now, we continue to have these discussions because it's heightened by the growing discussions that are happening globally, and we're seeing what's taking place at the conference, that's COP27, on climate change. In conjunction, we can all imagine and we see the visible effects brought on by our return to normalcy in a post-COVID environment, and that's the lifting of the restrictions. All of this has brought the subject of air quality to the forefront once again. In response, the title agencies that I mentioned before have convened respected minds of interest with the intent to deliver global knowledge on the discipline as well as to engage on a healthy discourse that would encourage practical and sustainable ideas. It's an exchange forum, a networking forum, but also where valuable information will come to the forefront to improve our areas and all areas discussed today. As one of the key stakeholders, we will begin this evening with a presentation from NIHERST focusing on the future-driven collaborations and all of the realities that are happening with this partnership.
As the leader in science, technology and innovation, NIHERST, we are pleased to partner with APETT on today's webinar, Finding Solutions to Engineering Challenges. As we work together towards this common goal, it is clear that we have begun to chart the course towards realizing tangible results. How did this collaboration come to the fore, you may ask? The synergy is clear between what we do at NIHERST and APETT. NIHERST, a statutory body currently under the Ministry of Education, was incorporated in 1984 to promote the development of science, technology and higher education in Trinidad and Tobago, and enhance the innovative, creative and entrepreneurial capabilities of the general population. Likewise, APETT through its professional body of engineers strives to stimulate awareness of technology and the role of the engineer in society. Both parties are indeed committed to future-proofing our nation. But how do we do this? At NIHERST, this is effected primarily through research and policy development, conducting statistical surveys for decision-making, digital fabrication and prototyping, and STEM, science, technology, engineering and math integration. Notably, this core offering of STEM integration further highlights the linkage between NIHERST and APETT. STEM places emphasis on innovation, problem-solving, and critical thinking, and together they make up a popular and fast-growing industry. But one may ask, how is engineering important in STEM? STEM is an integrated approach to learning. Engineering is what connects the disciplines. Engineers seek solutions to problems, then apply scientific knowledge and mathematics to design, build, and maintain technologies to solve the problems. STEM is necessary for growing the economy and staying globally competitive. More and more we see the synergy emerging. This partnership between NIHERST and APETT has been sealed by a memorandum of cooperation, with projects to include an Engineering Icons video series, feasibility study to establishing a mentorship or internship program, sourced from the APETT database, and this our tripartite public seminar series that addresses engineering challenges or societal pain points. As we are aware, today's session will focus on air quality. Noticeably, within Trinidad and Tobago's heavily industrialized areas, greater investment in air quality management standards is needed. By simple observation, vehicle emission, the open burning of garbage, and industrial activities are a few of the major causes of accumulated air pollutants. Air quality concerns also arise as a result of the Saharan dust, whereby its plumes are ramping up over the Caribbean region, creating health hazards that are particularly dangerous for those with their health compromised by COVID-19 or other problems. On top of that, the dust can contain hazardous materials such as pesticides and microbial pathogens. This particular societal pain point has the capability of seriously impacting our economy and the health condition of our citizens. The damages caused by this pain point include strokes, heart diseases, lung cancer, acute and chronic respiratory diseases, deteriorations to the environment and man-made infrastructures. According to a report from the World Health Organization, approximately 7 million people from around the world die every year from pollution-related incidents, accounting for nearly 320,000 premature deaths. The good news is that when we take action to improve the quality of the air, we make our environment cleaner, our health better, and reduce the impacts of the climate crisis. As a key stakeholder within this context, it is our responsibility to educate and also aid in the implementation of sustainable solutions. While we are aware that the enablers of air pollution cannot be eradicated with simple processes and one-off meetings, we are mindful that should we wish to enjoy a healthier and more sustainable environment in the near future, urgent discussions on how our agencies can aggressively combat such concerns must be advanced. We intend that from our live discourse the representatives present today will be encouraged to adopt responsible best practices as it relates to air quality management, engage in further conversations with their networks to respond adequately to the growing air quality crisis, become knowledgeable to identify air quality issues, promote healthy discourse that would lead to proper policy formulation and adoption on the matter, promote sustainable measures that would be proactive against the causes of air pollution, develop ideas that would alleviate the pressures felt by those already affected by the aforementioned, and invest in the educational processes that would reduce local air pollution levels. We are all in this together. Let's work together to make our nation a better place for all.
Thank you so much, NIHERST, for such an informative presentation. And as the last line said, we're all in this together. We truly and anxiously anticipate your upcoming endeavors as you continue to chart the course towards a STEM-enriched society and a STEM-enriched future. At this time, I'd like to welcome Professor Terence Simangal, the Dean of the Faculty of Medical Sciences at the University of the West Indies. And also joining him would be the President of the Association of Professional Engineers of Trinidad and Tobago, Dr. Chris Maharaj. They will provide some insight on the medical factors relating to the impact of the standard of quality, that is air quality, on the human body.
Good day, I'm Professor Terence Simangal. I'm Professor of Medicine at the University of West Indies, and I'm a specialist in diseases of the lung, or what we call respiratory medicine. I'm also Dean of the Faculty of Medical Sciences at the St. Augustine campus of the University of the West Indies, and it's a pleasure to have this discourse with you.
Thanks so much for taking the time to have this interview with us, Professor. This is a loaded question, but I would like to know what is the impact of poor indoor and outdoor air quality on our health?
Okay, so I guess that's a question a lot of people ask. But in the context of, if you ask the question in the context of Trinidad and Tobago, you get a different answer compared to the context of the world as a whole. So let's take the world as a whole. The context is pretty, well, the complications of indoor, or the implications of poor indoor air quality is greater in the developed world, where people use fossil fuels and so on. So maybe not North America, but in parts of China and so on. Well, in China developed, I don't know if you agree with that, but to me it is. So if you're using fossil fuels as a source of energy in the home, then indoor air quality becomes a problem. In our part of the world, that does not happen. So for the most part, we have not had much problems of those types of problems. So particulates and so on in the house, coal pots, for instance, in the old days, in the kitchens, would have meant that there's what we call biomass exposure. That's the terminology used in medicinal law. And such people are at risk for COPD as well as asthma, chronic obstructive pulmonary disease, which is a disease of the airways. The same thing that's caused by smoking cigarettes, actually. However, there are other issues of air quality, indoor air quality that have arisen in the tropics because we are trying to live perhaps a bit more like the temperate world. So we have air conditioners in our home, we have carpets in our home. There's no need for carpets in the tropics at all. Carpets are predisposed to having things like dust mites and various other little organisms, and they produce proteins which we call antigens in a medical sense, and they evoke immune reactions in some of us, and in some of us it's asthma. So that's one issue. But the other issue is with the air conditioning systems in a lot of homes and offices, where the air circulation, now I'm not an air circulation expert by any means, and we are very fortunate that in my office we have someone who specializes in that, and they've been very helpful. But the issue is you cool a room down, and outside you have hot air, and if the air is saturated to any extent, when it meets the cool air, you get condensation. And when you have regular condensation on surfaces over a long period of time, especially if those surfaces are not disturbed in any way, mold tends to grow. And this also occurs even if you can't see it in the room, in the air conditioning systems that we have in the piping that spreads cool air through large buildings. A lot of mold can happen unless they're regularly cleaned. And that is what influences a lot of air quality. Now, what is the effect of mold? So everybody thinks mold causes a lot of things. But if you have asthma, certainly the particulates or particle spores, we call them antigens in medicine, that spread into the atmosphere can make your asthma worse. So if you have any form of airway disease or lung disease, it can make it. It doesn't necessarily have to. It depends on how your immune system reacts to it. But can it cause? That one is not so clear. Other particulates can cause asthma. Little fumes, for instance, can cause asthma too. So that brings us to the other group of causes of poor indoor air quality at the workplace, and that is where you have a lot of dust, industrial dust, or industrial gases or fuels, ammonia, for example, chlorine. If these are not properly controlled, and if the air quality is not rigidly maintained, and it pops up every now and again above what you would consider your level for exposure, in people who are susceptible, you can have a problem. And then, whether or not you're susceptible, if you do have an industrial accident where a large amount of these gases get into the lungs, you can have long-lasting effects. So I guess that's a long-winded way of answering your question, but theoretically in the tropics with open homes, there should not be a problem. With darkness in the home, there can be a problem. At the workplace, air circulation issues, as well as the types of exposures that you will get because of the inherent work that's being done there, can affect the lungs. I should add one more thing though, and that is that while we consider that indoor air quality obviously will have the greatest impact on the lungs, there are cardiac consequences of it. The mechanism for that is still being investigated, but one of the theories is that these particles excite inflammation in the lung, or these gases or particles. And where does all the blood from the lung go to? It goes to the heart. And the first exit, when the heart pumps blood to the rest of the body, the first exiting pipes are the pipes or arteries that take the blood to the heart muscle itself. So they get a good dose, or can get a good dose of inflammation that comes from the lung. That's a theory that goes behind why there are cardiac effects of air pollution as well.
Thanks so much, Professor, for taking time again to have this interview with us, and we wish you all the best.
Thank you very much.
Thank you very much for that insightful and fruitful discourse. And that was Professor Simangal. Definitely, I think we all learned a lot. I surely did take a lot of notes. Participants, please remember that you can place your comments and also any questions that you may have in the chat box, and we will respond during our Q&A segment. This is a panel discussion, so definitely something you don't want to exit early. At this point, I wish to introduce you to our first panelist for this evening, Ms. Vinti Kaladin Ramdath. She's a technical officer too of the Environmental Management Authority. Mrs. Kaladin Ramdath has responsibilities which include, but definitely not limited to, the implementation of air pollution rules. This is also administered in 2 phases, and that's the emitter registration as well as permitting. Now, tasked with delivering objectives aligned to the EMA strategic plan, she's also involved in providing support for ambient air quality monitoring activities conducted by the air unit. Her support ranges from assisting with the maintenance of the existing stations at the EMA's ambient air quality unit and also monitoring the network as well. She also covers installation and commissioning of new ambient air quality monitoring stations, site selection, inspections, preparations, and that also includes data verification and reporting. Ladies and gentlemen, I would like to welcome Mrs. Kaladin Ramdath.
Good evening, everyone. Thank you, Ms. Ramkissoon, for that introduction.
And thank you for joining our discussion. So let me get straight into it because I know our audience is waiting. What does the EMA do from an air quality standpoint? And the second part of this question, what standards do they follow when deciding the ambient air hazard levels?
So thank you very much for that question. With regards to the first part, the Air Pollution Rules 2014 provides the legislative framework to monitor the emission of air pollutants into the atmosphere in Trinidad and Tobago. Implementation of the rules began in 2015, and actions taken by the EMA are aligned with the National Environmental Policy and the authority's strategic plan. So to address air quality, one must obviously know what is in the air. And through the public sector investment program, the EMA in 2015 established an ambient air quality monitoring network for Trinidad and Tobago. This network started with 2 stations and currently comprises 6 stations, 2 of which are currently undergoing commissioning. And these stations are distributed across both Trinidad and Tobago with locations in Port of Spain, Point Lisa, San Fernando, Arima, Port of Spain, Signal Hill, Tobago. We do have preparations ongoing for the installation of a 7th station in Tobago. And the EMA will continue to expand the network, of course, with funding through the public sector investment program. So to expand a little bit, these stations measure the criteria of pollutants, being particulate matter, both PM10 and PM2.5, carbon monoxide, sulfur dioxide, nitrogen dioxide, and ozone. And these pollutants are commonly monitored parameters in many other countries around the world, and they are thought to present the greatest risk to the health and well-being of the population of Trinidad and Tobago. These pollutants are associated with, for example, combustion of fossil fuel and industrial activities, which are common to Trinidad and Tobago. So the data that is recorded at these stations do undergo validation and comparison to the permissible levels in Schedule 1 of the air pollution rules. And I will expand a bit more as we go along into the structure of the air pollution rules. I do want to say here, though, that the permissible levels were found prior to becoming law by an international consulting firm with experience in regulations to be generally reasonable and within the magnitude as those from many other jurisdictions. So these standards are classified as primary standards since they protect against adverse effects on the health of vulnerable populations, such as persons with underlying health conditions, such as heart disease, respiratory ailments. So the standard for each pollutant in the air pollution rules, Schedule 1, would have different averaging times example, hourly or 8-hour average, some cases a 24-hour average. So these different forms of the standard are created and enforced to address varied health impacts that occur as a result of shorter high-level exposure versus longer low-level exposure. So the data that is collected and recorded at these stations is remotely pulled to an air quality management information system, where the measured pollutant concentration is converted to an air quality index. This is presented as a value on a scale of 0 to 500, and it's categorized by the level of health concern. So the higher an AQI value is, it means that the greater the level of air pollution and the greater the health concern. So for example, an AQI value of 0 to 50 represents good air quality with little or no potential impact or effect to public health, whereas an AQI value greater than 300 represents air quality so hazardous that everyone may experience side effects or serious effects. So the permissible levels in Schedule 1 are what the EMA will be guided by when determining air quality, ambient air quality. And these permissible levels are factored into the software algorithm for calculating the AQI value. This AQI is updated hourly and is accessed by and can be accessed by the public on the EMA's website real time. So you'd find, like, for instance, during periods of Saharan dust that we're all familiar with, the AQI value may increase. And this is because there's a corresponding increase in particulate matter concentrations. So in addition to the AQI value being reported, we also generate a quarterly report for the network. And this is published on the EMA's website and can be accessible by members of the public. So in a nutshell, that's basically some of the things that the EMA do in terms of addressing air quality and how we go about determining the quality of the air.
Thank you so much, Ms. Ramdak, for enlightening us with your expertise. I know that we will delve a lot further into this discussion, but it's also good to know that we are abiding to international benchmarking rules. Our second panelist is Elizabeth Sebran. Now, Ms. Sebran currently applies her knowledge in the field of environmental and occupational health for the last 12 years with Rose Environmental Limited. Her current experience entails environmental instrumentation and monitoring applications with consultancy and execution, including over 100 indoor environmental quality, that's IEQ projects in occupied building environments. Now, in February of 2020, she presented a paper on the elusive Chaetomia mold, an investigative case study. And also that was based, that event took place in the USA, in Florida in particular. Now, to date, she has co-facilitated local indoor environmental quality workshops in Trinidad and Tobago, and she continues to support WSP, that's the Golder Lecturer Facilitators, with Rose Environmental's hosting of specialized occupational hygiene courses by Occupational Hygiene Training Association and also the British Occupational Hygiene Society. I'd like to welcome Ms. Sebran into our discussion.
Hi, good evening, Hema, and thank you for that introduction.
Now, I know we have a lot to discuss. So again, like with our last speaker, I'm going to get straight into our first discussion. Our opening question to you would be, what defines indoor air quality and what are the main contributors towards poor indoor air quality? So if we know what's good, and let's know what's bad.
Okay, great. So indoor air quality is basically the quality of the air that you have within your buildings and structures. So this is a little bit different than from what you have in an occupational environment. So an occupational environment will have, it can have contaminants and so on that you can breathe in and you can have exposures. But indoor air quality speaks to the quality of the air within a building where occupants reside, and hence it speaks to occupant comfort and their well-being. So the US EPA defines indoor air quality as a space that has good distribution of adequate ventilation, a space that is adequately controlling its airborne contaminants, and a space where there is acceptable temperature and humidity. So the thing about indoor air quality is that it is based on a comfort perspective. So whilst in an occupational environment that is based on a health perspective, indoor quality is usually defined, well, good indoor quality is one where the substantial majority of the occupants are not expressing a dissatisfaction. So usually at 80%. So once 80% of the population in a building is satisfied, comfortable with that current environment, the indoor quality there is considered good. All right. So and now why would we even bother with indoor quality? So I mean, there is a growing body of scientific evidence that has indicated that the air within homes and buildings, office buildings and so on, it can be seriously polluted, even more polluted than the outdoor air for various reasons, even in the largest and most industrialized cities. So research also shows that even during the COVID-19 pandemic, that people spent a lot of time in buildings. Sometimes 90% of their day was spent inside a building. So because of this time in buildings, this exposure time, people are at risk to health that could be due to air pollution that could be happening in buildings versus outdoors. And the thing is that buildings, you have susceptible groups such as the very young, the very elderly, people who are chronically ill, people who are already suffering from other forms of respiratory or cardiovascular disease, make them even more susceptible to indoor air quality. So with that in mind, what contributes then to bad indoor air quality? So NIHERST found over 500 indoor air quality investigations in the last decade, that the primary sources were due to inadequate ventilation. So at least 50% of those studies were due to inadequate ventilation, meaning that ventilation was not sufficient and adequate to reach the occupants. And in that case, if you have sources inside a building, then you don't have enough ventilation to clear that space. So then another contributor to poor indoor air quality is contamination that happens inside of a building. All right, and inside sources could be things like new carpeting, not giving all that nice new carpet smell, that's probably formaldehydes or VOCs. Environmental tobacco smoke. If you have any type of furnaces inside a building that can give off carbon monoxide, copy machines that give off VOCs, the use of cleaning agents and pesticides in buildings also give off VOCs. So these are sources of contaminants that can originate from inside a building. Then another contributor to poor indoor air quality is when contaminants come from outside and get into the building. And this could be from sources such as motor vehicle exhaust. Or if you place your plumbing vents in such a way where the air can be re-entering back into a building, such as bathroom exhaust or kitchen exhaust, or even exhaust from parking garages that can get re-entering back into the supply air into the building, then that is an outdoor source that's getting back into the building and potentially contaminating the indoor air. Even the placement of dumpsters in relation to building intakes or building windows could also be an indoor air quality risk. And there's also biological contaminants. So if you have proliferation of biological contaminants such as molds and bacteria in a building, that can also contribute to poor indoor air quality. So cases of high moisture, high relative humidity, that could cause mold proliferation. If you have more standing water in a building, such as in flooding events and so on, this is where bacteria start to take dominance, and both can grow and reproduce in these conditions, and they release toxins and viable material, non-viable material that can be inhaled by persons in the building, resulting in potentially health effects. And the other last contributor to poor indoor air quality is temperature and humidity. Now, temperature and humidity is your basic parameters. So in essence, low temperatures, you'll have complaints for cold conditions. High temperatures, occupants will also complain. And sometimes these high temperatures are not necessarily due to, the cooling capacity of your air handler system. It could even be due to poor airflow, poor indoor air circulation in buildings. Now, we live in a hot and humid climate, so we don't really have instances of low relative humidity, though it can occur, but when it does occur, it can cause dryness of the skin and the sinuses. And in a case where there's high humidity, then you have increased risk for moisture in buildings, and then your risk now for fungal and microbial contamination now increases. And also, just to note that cold temperatures combined with low relative humidity can be more favorable conditions that can increase the spread of viruses. So this is just a brief intro to some of the contributors to poor air quality.
Thank you so much, Ms. Sibran. I think the entire audience is now making a list to do a home audit. I definitely will do one as well. Thank you so much. Now, adding to the list of invaluable information being presented at this webinar, we wish to usher the thoughts and the experiences of Mr. Rishi Shafi. Now, Mr. Rishi, and Mr. Shafi, that is an environmental engineer at Kariri with over 10 years of experience in identifying and investigating health and wellness risks at their workplaces. Now, this range from chemical, physical, and biological hazards, and developing strategies to eliminate them or also minimize them and combat them. He is responsible for the planning, execution, and completion of occupational hygiene surveys and indoor air quality assessments of all clients of Kariri. Mr. Shafi was recently issued a title of Certificate Industrial Hygienist, that's CIH, by the Board of Global EHS credentials, and that is as well as the Council Certified Indoor Environmentalist, and that is by the American Council for Accredited Certification. He holds a Master's of Science in Environmental Engineering and a Master of Science in Occupational and Environmental Health and Safety, as well as a Bachelor of Science in Physics with a minor in Environmental Physics and Material Science, all from the University of the West Indies, St. Augustine. We want to welcome Mr. Shafi to the discussion.
Thank you, Ms. Ramkissoon. Good evening, everyone.
Good evening. Now, I know we are sort of setting the stage for our Q&A segment, so let's get straight into it. Ms. Shafi, how does one determine the quality of air within residential, commercial, or industrial buildings?
Okay, well, the best way to determine the air quality in a building is to have the air tested and the AC systems inspected. And when we have all these data and information, we compare them to regulations and standards. And for the commercial as well as the industrial settings, these are occupational exposure limits we would tend to compare to. And for the residential side, those are more for the community-based standards given by the EMA. As well as for the ventilation systems inspections, we tend to look at standards that are based in the international. This is because there are no local or regional standards that we can apply to. However, there are well-known and well-respected standards from the United States. If we were to delve in further into the having the air tested, there are many parameters and many methods we can employ to go about testing the air. Some of them may include gases such as carbon dioxide, which is an indication of ventilation, as well as VOCs, other organic compounds and inorganic gases, which can give us indication for symptoms and malodors. There's also the issue of thermal comfort, where we can look at the temperature and relative humidity, also the moisture, where we look at the dew point levels, and also the particulates, particle counts, particle size, as well as fiber counts. From a biological aspect, we can look at mold, where we can have samples taken from the air, as well as if there's any suspected sample on a surface, we can take a sample from that. In addition, there are allergens, where we can sample for dust mites as well as pollen. And finally, bacteria, and something of recent concern, COVID-19 aerosolized droplets in the air. So when we have all these values, we take them, we look at the ventilation systems as well. And what that means is that we look at the design aspects of it, the types of filters installed, the insulation, the location of the outdoor intakes. We would also look at the condition and the usage of the units. We look at the performance of the units, and also the maintenance and the cleaning regime of the units, as well as the building. And together, both holistically, this would give us a idea of the quality of the indoor air, and with the ventilations inspection, it would provide us with recommendations that, if any, are needed to rectify and improve the quality of the indoor air. Thank you.
Thank you very much. And I know that we will delve a lot deeper into that discussion during our Q&A segment. And I want to also tell you, Mrs. Shafi, that your contribution was definitely crucial in achieving the objectives of the discussion this evening. We also are mindful that the subject of air quality warrants immediate attention. Besides such, the drive towards the alleviation of its present standards requires a solution that is both innovative and takes into consideration the best interests of all stakeholders. And we do have a wide range of stakeholders present. In light of this, you are reminded that you are more than welcome to submit any questions or comments that you may have for the panelists. There is a comment section in the chat box, but also we are streaming live on various platforms, so you can also send in your emails as well. Now, coming to the center stage at this point is Dr. Hemwati Babulal, an environmental scientist. Dr. Babulal has spent her entire career in cross-discipline environmental research, having worked from the ground up literally as a technician in the Institute of Marine Affairs, through 2 postgraduate scholarships, and now on to her recent position as a lecturer in the Environmental Science and Sustainability Technology program, that is at the Faculty of Science and Technology at the University of the West Indies. She has been formally trained in epidemiology, analytical chemistry, microbiology, pollution biology, environmental management systems, toxicology, and ecology. Her areas of expertise are wide, but they also cover indoor, outdoor, and industrial air quality, pollution assessment, and modeling, also statistical data analysis, and the environmental risk impacts assessment. As you can tell, she's well qualified to be part of our discussion, like the rest of our panelists. She's also looking at, and just to give you a greater idea of who she is, she holds 2 Bachelors of Science degrees from the University of the West Indies, a BSc in Botany and Zoology, and a BSc in Occupational Health and Safety. She would later obtain her master's degree in Environmental Science, graduating with distinction from the University of Strathclyde in Glasgow. And also Dr. Babulal in 2021 was awarded her PhD from the University of Trinidad and Tobago in Environmental Studies. Dr. Babulal, welcome to our discussion.
Good evening, and thank you for that intro.
I want to go straight into our question, because I know from your wide, and I did say you are cross-discipline in terms of your approach to looking at the topic. So I want to ask you, what would you say are the top 3 challenges that we are tasked with in improving the quality of air that we breathe? We've heard so much about commercial, residential, and everything in between, but every single day, what exactly are we taking in, and what are the challenges for improving the quality of air that we breathe in the country?
I think the first thing we should do is determine what we mean by air quality. Air quality is actually a concept that is measurable by the amount of pollutants in the air. And from our previous panels, we get an idea that the pollutant levels and the pollutant loading in different areas can be quite different, both in the chemical nature of what is there, what makes up the pollution, and the chemical nature and how much of it there is. So ambient air pollutants in an urban area will consist of different things from an indoor environment, which would be different from an occupational setting. So in different regards, we have different dynamics to deal with. So the first thing we should do is try to wrap our minds around the fact that there are many different kinds of pollutants. A pollutant is any substance that is aerosolized that exists in amounts that is uncomfortable to human beings, or which can pose discomfort or harm to human beings, or pose a threat to the environment, such as we're all familiar with greenhouse gases. Now, many of the greenhouse gases are organic chemicals, chemicals that absorb in the IR range, and that's why they have that global warming potential. But many of these have anthropogenic origin. Some of them are xenobiotic, meaning that they do not occur anywhere in nature. They were all created by men, by humankind. There are also natural pollutants like Sahara dust that affect the ambient environment. So understanding what the pollutants are, we do have the technology to assess all the pollutants in the different zones, and there's certainly more than the 6 criteria pollutants. We certainly do have more things in our air than carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, and particulates. We have particulates in every different size. And size matters when it comes to particulates, because the smaller particulates, the deeper it's able to penetrate into the lungs. The deeper it's able to get into the lungs, the longer it stays there. And then the more important, its chemistry, what's stuck onto those particulates, comes into play, because that is what gets absorbed into the bloodstream or interfaces with the cellular tissue that can have other effects, other health effects. So that's the first thing. The second thing is the public awareness that that air pollutants we create, not only do our pollutants come from industrial sources, so that we know about 80% of our greenhouse gases come from the industrial sector and the power generation sector. But that doesn't absolve the other 20%. It does stem to reason that because these are the 2 sectors that most of our greenhouse gases come from, that a lot of the pollution also comes from there. But we spend a lot of time indoors, and indoors we generate other pollutants. Like if we put on a gas stove, that has incineration products because it's natural gas that we're burning. If you truncate pots, you generate a lot of, you have a bump up in the amount of particulates. Now the chemistry of that particulates matters, and the size of the particulates matters, and the type of gases, whether or not it's harmful or not harmful, also matters. And what matters in a household is the ventilation issue. Inside a house, simply opening a window or venting your gas stove would help quite a lot. Another issue in indoors is that we're not aware of is, I remember speaking to a lot of people during COVID, where they said the AC is on, so we lock up tight, we're fine. But the thing is that a lot of respiratory viruses, including COVID, COVID highlighted this, that biological agents, respiratory diseases spread indoors. It's spread indoors because the ventilation is often not as good. The indoor air quality, be it inside our homes or inside a tightly shut building or inside our cars, is generally a poorer derivative of what is outside. Mm-hmm. So it's generally a good idea, if your air quality outside is okay, to keep a window or 2 open to make sure you have that exchange of gases. Because many of us go from our houses to our cars to our workplaces, and we spend a lot of time in indoor controlled environments, which may not have good air quality. The third challenge I think we have is our fossil fuel consumption. Most of our transport fleet is fueled by diesel. And the thing about burning diesel fuel is that even though it burns more efficiently than gasoline, it also generates a much larger amount of fine particulates. And what these fine particulates do is, the finer it is in the ambient air, it's going to stick around for a longer time. So PM1s, for example, that's particulates that have an aerodynamic diameter very tiny, of less than 1 micron, they would stick around for a long time, and they usually gas phase reactions, and it can stick around for about 100 years. 100 days in the environment. And if we are outside and we breathe those in, those get absorbed into our lungs, go deep into our lungs, and any molecules, any organic substances, any inorganic substances, any trace metals that are stuck on those particulates would be what's interfering with our cellular chemistry inside the lungs, and then eventually enter into the bloodstream. So giving some serious thought to how we can transition away from diesel into some things that are more healthier fuel that will contribute less to global warming, and 2, be healthier for our population. In Europe, they're moving towards tripartite fuel, like using hydrogen as well as solar power, as well as maybe CNG, as well as electric. So using a combination of all of those, so we get where we have to go in our cars without contributing that much more to pollution. So I think as a society, a small country, that if we wrap our minds around what our sources of pollutants are, the fact that we as a house, as each individual, can play a role in the products that we use and how we use them, how we spray pesticide cans, how we burn things, because whatever you burn, you take from solid form or liquid form and aerosolize it, and you can spread it further. We all have a part to play, and that policy should reflect where our major sources of pollution come from. So power generation sources, industrial sources, and what goes on in the household and what comes out of our tailpipes and our vehicles should be the targets of policy to address what our pollutant production are.
Thank you so much. And I know it's a lot to digest at this time, but Dr. Bablal, I want to thank you so much for extending your research to us. Certainly your studies matter, and they have encouraged all of us to pay a greater emphasis on the standards within our immediate environment. At this juncture, ladies and gentlemen, we did mention that this is an interactive forum, one where we do want you to get involved. We are going to start opening the floor for the questions that we have coming in. We have a whole lot of questions. I know we have about 30 minutes for a Q&A segment. So I want to first of all thank our panelists, but I want to now get into the Q&A because we had some opening questions. So I'm going to start with some of the questions that we have received thus far. And this one is directed to our EMA representative. And this question goes, what legal framework exists for the EMA to take legal action against violations with respect to air quality? Because we're looking specifically at air quality.
Thank you for that question, Hema. So at the EMA, we do have subsidiary legislation under the Environmental Management Act. Specifically for air quality, we have the Air Pollution Rules 2014. The rules are administered in two phases: source emitter registration and permitting. So upon implementation of the rules, all emitter facilities were required to apply for source emitter registration. We found the majority of industries and manufacturing sector has applied for source emitter registration. Now, source emitter registration is basically an inventory of emission sources, which includes identification of the emitter's point and the concentration of air pollutants in ambient air, and also that being released at the point of emissions, be it a stack. The air pollution itself has three schedules. Schedule 1, which comprises a list of pollutants and permissible levels. Schedule 2 is similar to 1, but applies to stack or point sources. Schedule 3 comprises a list of designated activities. So any facility conducting any of the designated activity and emitting any of the pollutants listed in Schedule 1 or 2 is required to apply for source emitter registration. So once the EMA is satisfied with the information provided, including air quality data, a registration certificate is issued. At any time after the issue of the certificate, the EMA can serve a notification letter requiring that a registered facility, apply for an air permit. Now, also, the rules allows for an air quality assessment to be requested at any time, either during source emitter registration or after. So the permitting phase, a permit is issued for a period no more than 5 years, and the intention is to bring a company into compliance with the limits listed in the air pollution rules. And this is done by setting and achieving those reduction targets agreed to. So for example, a facility may implement best management practices, they may use control technology, they may implement an air pollution management program. So these permits are monitored. There's a requirement for frequent monitoring data or reports that have to be submitted. These are evaluated for compliance with the rules. Now, with regards to other activities conducted at the EMA within other units through the CEC process. A CEC may include conditions for air quality monitoring and, by extension, air management of air pollution at a facility. So where a facility is shown to not be in compliance, the facility must demonstrate by implementing mitigation measures how they're going to address those non-compliance issues, and it must be to the satisfaction of the authority. If mitigation action fails, then the EMA can pursue legal enforcement under the EM Act. So the EM Act basically provides the framework for enforcement action with regards to air quality and the other processes conducted at the EMA.
Okay, thank you very much. Thank you. I know that was a lot to take in. Now, this is one directed to Rishi Shafi, and this is specifically from Kariri. And I know this is from, like myself, I have a lot of air fresheners in my home. We have a lot of candles. We use a lot of those, making sure that your environment does have the ambient smell, I guess. So Rishi, do air fresheners contribute to poor indoor air quality?
Thank you. That's a great question. Well, these air refresheners, they are more of a odor masking control. However, it depends on the concentrations or the chemicals that are inside of these air refresheners. Now, if I were to do an air quality test, while these air refresheners were sprayed and they were found to have some chemicals of concern, then they would contribute to poor air quality. That being said, there are some individuals who are more susceptible to others. And in terms of odors, it's more of a preference. So what you introduce into the environment, it may actually affect someone else, but you may be okay with it. So in instances like these, it all depends on what you use. The common household ones that you see in the supermarket, normally they are based on, there were numerous tests done to ensure that these are safe. But however, there's no way to tell unless we have a proper quantitative assessment to see what is that is being emitted and being circulated in the environment.
I think a lot of people will be coming to Kariri to definitely get some tests done as well. But thank you so much, Rishi. I'm returning to our EMA official, and this is really another one. How does the EMA or other regulatory bodies plan for discovery and investigation of poor air quality conditions, particularly in the manufacturing facilities locally?
Hi, thank you. I think that question needs some clarification. It may not necessarily be from an ambient air quality perspective. That may be more from an occupational setting. So maybe
I'm going to ask if the submitter, those who submitted the question can clarify. But if you have to look specifically at, I guess, if you look at the manufacturing sector in particular, are there random checks and looking at the investigation? What does the investigation entail if a report is made?
So once a CC is issued to a facility, there are conditions in there. Those CCs are monitored by our permit monitoring and complaints unit. A report is generated internally. If a facility is not in compliance, because they are required under the CC to provide monitoring data, and the frequency for that monitoring data, the parameters, it's included in the CC. So if a facility is not in compliance, they are given the opportunity to come into compliance. If over time, though, it's seen that they're not in compliance, it can be referred to legal services for enforcement action. We also get complaints that comes to the emergency response and investigations unit. So those complaints, they're investigated, a report is generated, and could also be referred to, say, for instance, the A unit, the CEC unit, if a facility is found to not have a CEC and they are conducting one of the designated activities, or it can also go to legal services unit for enforcement action under the EM Act.
Okay. And I know if the individual who submitted that question, if there's an additional part of the question you'd like clarified, feel free to put it in our chat box. Now, this is for Elizabeth. With our given climate and the long-standing office buildings and considerations to the policies, the testing, the humidity, the monitoring, etc., if any are given to indoor mold, so I guess they're looking at the age of the buildings that we have and looking at what's happening. Is any consideration given to mold or mold-associated buildings, illnesses in these buildings, and what are the regulations, standards, or reference on this? I think either Dr. Babalal or Elizabeth can take this one.
Okay, I can give a bit of clarity for this.
Sure.
So the thing is, right, mold is often a very misunderstood topic in the field of indoor air quality. Yes, we do live in a very hot and humid climate. Yes, some of our buildings are old and maintenance may not be the way that it should be. So you can have conditions at times that could increase the risk for indoor mold, and the associated illnesses are usually due to occupant susceptibility. So if there is an occupant who maybe they have respiratory susceptibility, they may be at more of a risk to an indoor mold exposure than, say, a healthier occupant. A healthy occupant may experience health effects, but it may not be, it could be a different type of health effect. They can experience something more mild while somebody else experiences something more severe to the same mold. So the thing is, right, mold is something that it's a contaminant that grows. It is affected by the building environment. So and it's not just mold. Mold is made up of many different species of fungi, and these different species, some of it can cause varying types of allergies and illnesses and so on. So so let me see the question again. Regulation and standards. Okay, so there are no regulations and standards for mold that are acceptable in the world at this time. And you may ask, well, why is that, right? Okay, so mold is very ubiquitous, all right? So one could expect to find them outside and inside a building. Now, mold is also governed by climate, whether it could be a microclimate in a building, whether it could be seasonal climate, whether it's depending on where you're located on the globe, whether it's the climate in the day versus the climate in the night, all right? So all of that, so like if you have, for example, dry environment, like say like you get up and it's dry in the morning, then you have a rainfall event. Sometimes these rainfall events could cause release of mold spores that were not released before. So climate plays a impact on mold. There are also variations in vegetation types and extent of vegetation worldwide, right? Mm-hmm. Now, you can also have fungi, it grows. It has a life cycle. So different ones have different life cycles also too. And then fungal spores, some of them are very small and they can stay airborne for a long time. And some of them are actually quite big and slimy and wet, and they just, as soon as they get expelled, they just fall out of the air onto surfaces, right? So, I mean, all of these factors are like limitations in trying to determine at what particular level can mold produce a health effect in persons. It varies for various different reasons because of the type of how mold is and how it grows, how it interacts with the building and climate and so on. And then there is individual susceptibility to it. So because of all of these different factors, like whatever mold is present in California in the US, in their environment, there is not the same thing that we have here. So a standard, for example, that could have been, or a guideline that may have been proposed for the western side of the United States will not work for here because our fungal flora is different here. So what is usually done is that we compare let's just say you have an incident in a building, a possible mold incident, we will compare indoor mold levels to outside levels. So we know when we go outside, we feel well, right? So we feel well, there's good airflow, we breathe in the air and we're fine. Remember, mold comes from outside, right? It's in your soil, it's on trees, it's in the environment naturally. Sometimes when you go in buildings, we may react to that same mold that we were breathing in well outside. So what we do is we take outside levels, we take outside samples, and we compare it to indoor samples. What you can also do too is compare complaint areas in a building to another area in a building that did not have a complaint. Another thing you can do in a case where you don't have a mold standard is you can look at indicator species. So certain molds have certain characteristics about them that tells us, hey, if this particular mold is growing here, then we have this particular concern with the building. So we can look for indicator species. And you put all of these together and you do a risk assessment, and then you can tell, do I have a risk for mold? What level is your risk? And then what you need to have done to rectify the problem.
Sure. Rishi, I don't know if you have anything to add to that contribution.
No, I think Elizabeth covered mostly everything.
Okay, Elizabeth, there's another one coming your way as well. If a building is continually having issues, and I guess mold seems to be the big question. So if a building is continually having issues with mold and moisture, and all the remedial actions were done to keep the mold at bay, such as regular cleaning of the AC units, maintenance of temperatures throughout the building, installation of humidifiers and dehumidifiers, air purifiers, treatment of mold in the affected areas via antimicrobial applications, what more can be done to reduce mold and moisture levels in a building?
Okay, that's a very good question because we get this all the time. So what you have to do, right, is understand that the risk for mold in a building goes up when you have a moisture problem. If the building is not handling moisture, you're going to have the risk will increase, and then you can possibly have a mold issue. Now, the moisture could come from your humidity, which is your general humidity in the building, and then your AC system is supposed to take care of that humidity. Or you can probably have water intrusions. Let's just say when rainfall falls and the water beats up on glass and the water gets into, let's just say you have a gypsum wall and the water gets into that, then you could possibly have a water intrusion problem there. Or let's just say you have a flooding event and you had a lot of a whole floor of a building, all the materials got wet. All of those are moisture concerns for a building. So I think the question that is being asked is that, you know, if you have this issue and you're cleaning your AC, you're maintaining the temperature, you're using dehumidifiers, why still have a problem?
Yeah.
So I'll answer with a case study. So I recently did a case study. So a client was having a problem just like this. So what we had to do was investigate the air handler system in great detail. So what you need to do is look at your air handler system. Is it oversized? Is it in a condition where it's not handling the humidity in the air properly? Maybe it has too much cooling. So the facility personnel would probably cut back some of the cooling because you have occupants complaining it's too cool. When that happens now, the airstream is not being cooled properly. It's being cooled, but it's not taking all the moisture properly because it's not being operated efficiently. It's being operated for the comfort of the occupants, but it's not being operated to remove the moisture. So in a case like that, you could have cool air with a high moisture content getting back into your building. Next thing I would probably look for is the distribution system. So I would look at your ducting. The duct layout, the size of the ducting, is it big enough for the airflow? Does the ducting layout match your indoor layout? Is it that you are having reduced airflow at the very end of the duct? Is it that you're having noisy vents and so on? Your airflow via the ducting could influence the airflow and the air exchange rate in a space. And that, along with moisture in your air, so if the air is not being handled properly by the AC unit, then you can have this condition where you have repeated building-wide mold contamination issues also too. So the first thing is look at your air handler system. Is it oversized? Are you cooling properly? Is it that it's too cold, so you have to raise the temperature, and because of that, it's less cool, but then it's not handling the moisture properly. Because remember, we live in a hot and humid climate. We can get moisture levels outside, humidity levels outside as up to about 80-90% sometimes. So for a building has to be able to handle that. And the acceptable level of humidity in a building is below 65%. So once you're below that, your risk decreases. Once you go above that, your risk increases. So I hope that kind of answered the question.
I think it was very clearly articulated. Rashida says one directed for you. Are home air filtration systems useful in minimizing internal air pollution?
Thank you. Yes, that's another great question. I've done a study of looking at the air purification units, and in just over one day, they were able to reduce the amount of particulates in a room from a class 10 to a class 8, meaning that it was able to jump by over 2 classes, meaning that it significantly improved the cleanliness of the indoor air. That being said, what you need to ensure is that the size is adequate based on the room dimensions. So there's something called a CADR, where you'll have to calculate based on the size of the room and ensure that the size of the air filtration device would be beneficial to assisting to clean the air. Now, the smaller units, it may take quite a while. And I would say to see any significant improvement, the bigger they are, the better they are, just completely removing the particulates. And over a period of time, you would see substantial decreases. And in many environments, they are being used now, especially in the healthcare systems, particularly in the ICU units, as well as other critical units, where the controlling the amount of particles in the air is of a serious concern. Thank you.
Thank you very much. Now, this one is either for Rishi or Elizabeth, so either one of you can take this. In considering environmental impacts when engineering or planning public waste management, have any feasibility studies been conducted for the use of incarceration systems? Example, principle of incarceration versus combustion with wet or dry scrubbers, or the reduction of emitted particulates. There have also been developments to reduce the energy waste by generating electricity from the residual heat for the incarceration or the incarcerated stacks. So either Elizabeth or Rishi can take this one.
It's a bit out of my my spectrum of field. I think this is more in the environmental air pollutions. In terms of, if I can understand the question a little bit more, to my knowledge, I don't know of anyone, or in terms of media or news, I haven't heard of any type of way. However, there are some companies who deal with incineration and dealing with waste, and they employ quite high temperatures that are able to minimize the amount of effluent or gases being emitted that are harmful. So in terms of the energy conservation of it to produce energy, I'm not sure that that's probably on a national scale, where you would probably looking at governmental and even the public utilities departments.
Now, Rishi, looking at are there any statutory requirements to continually test and monitor in commercial or industrial buildings?
Thank you. Well, in comparison to what the EMA has, there isn't anything directly states that companies have to go about conducting indoor air quality tests or looking after the air quality in workplaces. However, indirectly, there are a few clauses from the Occupational Health and Safety Act of 2004, amended 2006, where in Section 6, these general duties of the employer, which states that, you know, they are required to ensure the workplaces is safe as reasonably practicable to ensure that it's safe for occupancy, as well as Section 13A, which is more of a strong point, where it states that employees shall make an annual risk assessment. And in this risk assessment, it has to assess all the risks that employees are being exposed to. And one of the risks is the exposure into the work environment, particularly indoors. So when you have to do an annual risk assessment, and in order for you to do this risk assessment, you need to have quantifiable data. And this is where the indoor air quality assessment will come, and will have the recommendations addressed so that can assist you with lowering the risk to acceptable level.
Now, I want to also bring the questions back because I know we've been getting a few and I know we're tight for time. This is for the EMA. Will there be a mobile air quality unit for site-specific measurement?
So if this question is in relation to ambient air quality at sites, the EMA do not do monitoring for facilities. We provide the parameters, we provide the monitoring frequency, we provide guidance on the methods that can be used. However, we do not do monitoring for facilities. The onus is on facilities to do the monitoring themselves, either through service providers. If it's in relation to indoor air quality, maybe one of the other panelists could respond to that. The only monitoring that the EMA does is through the ambient air quality monitoring network or through our investigations unit, the emergency response and investigations unit. But that would be conducted specific to an incident and in support of the investigations.
Now, thank you so much, Ms. Ramdat. This is specifically, I know this is a question that seems to be a common trend, and this is for Dr. Babulal. According to health stats, what are the most common respiratory ailments that occur due to poor indoor air quality?
Right, good evening. So thank you for that question. Like was said by both Rishi and Elizabeth, indoor air quality is a poorer derivative of outside air. So usually what you have outside, you usually have inside and then some. The health effects of most air pollution. Now, we do have many different kinds of pollutants, and you did talk earlier about incineration. What incineration does is simply aerosolize more things into the air. Whatever is there in the ambient air, people breathe in. At lower concentrations, you tend to have chronic effects for exposure to air pollution, and this exposure to toxic stuff, as well as dust, as well as mold that fit a particular size. As pollution levels increase, you tend to have more serious effects. So the usual effects for lower levels of pollution tend to be things like COPD, asthma, and asthma can be induced in otherwise healthy people when exposed to contaminated air, and chronic bronchitis. Chronic bronchitis occurs because there's this overproduction of mucus because the trachea and the esophageal lining is reacting to being stressed and being exposed to things that are irritating. So it produces a lot of mucus and you have this chronic cough. But there's sometimes, since 1992, there have been Cancer Society studies 1 and 2 studying hundreds of thousands of people, following them over the years, where at high levels of pollution, I'm talking about particulate levels, about 50, 60 particulate levels that we have in Trinidad in our industrial and urban areas that show a distinct bump in levels of deaths from cardiovascular disease and from lung cancer. Sure. The thing is, we've known for a long time that the most serious effects of breathing in bad air is lung cancer and cardiovascular disease. And during the course of low-level pollutants, most of the deaths that occur happen because of exposure, chronic exposure to this particulate levels. And it usually occurs in a linear fashion from lower levels, about 10 relatively clean air, 10 micrograms per cubic meter, to about 50, 60, and then flattens off. And above that is where the cancerous tends to bump up. So it's actually been talked about many times. We know how different toxic chemicals can affect our bodies, and we do have in our ambient air, and worryingly so, many toxic contaminants in our air that exceed exposure for safe, well, levels for safe exposure. And I'm talking about international guidelines that are non-binding. American Conference of Industrial Hygienists produce an annual schedule of exposure to different chemicals and what the health effects are. The WHO produced guidelines where the particulate level that is generally safe, deemed safe for public exposure, are 5 micrograms per cubic meter, PM 2.5. Nowhere in Trinidad has that level. In fact, 99% of the world live in conditions that exceed WHO guidelines. So almost all the air we breathe, for most of us, do pose some level of public health risk. But controlling what we can in terms of, for the industrial sector, for the power generation sector, knowing what's there and trying to push organizations to do what they need to do to control their emittance for in the household, to try to allow people to know that they can control the contaminants they have by venting and by not using things like a lot of insecticides inside, not burning coxswain inside to have DDT incorporated into their bloodstream. Those things would help in eliminating some form of disease. Certainly, as Dr. Simongal indicated, carpeting is a bad idea in the tropics because it's like a rich ecosystem for mold and mites and lots of living things. So what I'm saying is that we do have levels of pollutants that do cause harm, and the most amount of effects are usually the chronic effects, the asthma, the COPD, allergic bronchitis, allergic rhinitis, that's overproduction of mucus and these allergic reactions. But it can also result in serious effects like inducing and causing lung cancer in non-smokers and children. And it can result, anything that stresses your lungs will stress your heart, and it can result in a bump up and increase in death from cardiovascular disease. So, and that's besides the effects of climate change, because the effects of climate change also have a death rate associated with it and human suffering associated with it.
Sure.
And these very same pollutants are the very same ones that are causing public health harm.
I know we're all going to take a definite note of that, particularly the carpeting factor. A lot of people are now going to relook their home design plans. I do have our last question. You know, as you say, things do fly, time does fly very quickly when you're having fun. So this one is for Elizabeth. You get the final question for tonight. What are your comments on the use of demand-side ventilation strategies to meet the current ventilation standard to maintain comfort levels and also mitigate against the formation of mold? What do you think is the best way to apply this type of ventilation system in a building operating in a tropical environment?
Okay, that's an interesting question. So demand-side ventilation is what I gather is where you actually control indoor, outdoor air. You control the amount of outdoor air getting into a space in an effort to save energy, especially if a space has some reduced occupants, if it's unoccupied for a certain amount of time, or if it is you have some kind of reduced use for that space. I think this is where demand control ventilation would come in, and it's really from an energy conservation perspective to save energy in the building. Because, you know, when you bring in air into a building and you have to use blowers and so on to pull the air in, and then you have to cool that air and filter it and everything, that costs energy. So that's what demand control ventilation speaks to. It's just a form of saving energy. Now the thing with this is, right, when you're doing when you're employing methods to save energy and so on in a building, you may be putting the building at risk of having reduced airflow because you're reducing the outdoor air coming in. So you may have some reduced airflow, you may have some reduction in your air exchange rates. You may be putting the building in a position where it may not be, they can have a situation where it may not be cooling the air sufficiently as possible because there is no need to, because there is nobody in the space. So even though it will result in some energy savings for the building facility owner, the building operator, and so on, it can cause secondary effects, and those secondary effects of reduced airflow or not being 100% functionality. You can end up in a situation where you may have the air is not being cool enough to a suitable level to maintain that indoor humidity, and then you can have a possible increased risk for indoor humidity levels to go above 65%, and then you can increase the risk for mold contamination as a result of that. So the risk does increase if you do apply this. It can be done. Now, the thing with indoor air quality is that the indoor air quality came about because of poor indoor air quality became a thing because of energy. So the energy embargo in 1973, I think it was, when buildings became tighter and it became expensive to operate and to bring in sufficient amounts of outdoor air, and then what happened is that outdoor air supply into the building began to cut back in an effort to save energy, and that is when these problems started to occur. So demand control ventilation, it does exist, but just take note that if you do employ something like this, you can put the building at risk for another problem afterwards. So with respect to a tropical climate, just know that our climate, we do have a high humidity level, especially at certain times of the year. So there's never really a condition where we are at a low humidity level. So we are consistently dealing with high humidity. So whenever you employ these methods, you're going to have a space that's, locked up or probably not being aired out properly, and then the moisture building. And then, you can have this increased risk for mold. So if you are applying this, you need to find that balance where if you apply it, you don't apply it to an extent where you increase that risk of mold. So the building facility owner will now have to work with like a HVAC contractor or a HVAC engineer to find that kind of balance where you can apply this, but don't go too below a certain level where you increase that risk for mold. So it's really about finding a balance to reduce the risk for mold. So remember, mold is inside and outside. Is the conditions inside that can increase the risk for growth. And that's what we're trying to prevent. So you're trying to always have enough air exchange and airflow, and trying to always control the humidity. So those are things that you have to keep in mind when you're using demand control ventilation, if you want to ensure that that space does not become a risk for indoor mold contamination per se. So I hope that answered the question.
Thank you very much, Elizabeth. I'm sure that you definitely did catch and capture the salient points. We have come to the end of this seminar. I want to thank all of our panelists for your insightful answers as well as your participation. I also would like to thank everyone. I can say for sure that this webinar has exceeded all expectations. The pertinent information, the valuable ideas, all of the networking that will take place as a result of the interactions allowed us all to widen our perspective on a very important subject. I also want to thank all our specially invited guests, all of our attendees, also those on behalf of NIHERST and APETT. And I also want to say special mention in closing to those who supported, from the NIHERST president, from all of NIHERST, from the president, that is Mrs. Marlene Lord Lewis, Ms. Candice Hector, the manager of marketing and communications, and the team at NIHERST, the ICT department, who came out very early today to ensure that we got all our lighting and all of our sound checks correct and all done. Also APETT president, Dr. Chris Maraj, and Ms. Shalini Pasar, Prasad, and other members of the mechanical division. Permit me once again to express our sincerest gratitude for taking time from your very busy schedules to be part of this information sharing session. Also, a reminder that an email is going to come in. We want to get your feedback. So please, we want to hear what you thought of this webinar and assist us in shaping our information sessions for the future. Again, stay tuned to all of the NIHERST exchange outlets as well as our social media platforms for the future webinars as we continue to find solutions to engineering challenges facing our country. It is only through events like this that we can truly develop. I'm Hema Ramkissoon. Do have a very safe and wonderful evening, and thank you again.